The answer to number 1 is in this absolute value inequality is x is in between -2 and 8, and that's an open set. It's not inclusively. This happens to be in set builder notation. This is the original problem right here, and you can maintain the inequality symbol, and then when you do less than -5, you'd have to flip it. So the little trick here in putting it into the calculator to see which direction the calculator goes is an excellent way of seeing shading. You just have to remember that when you do a zoom 6, you're seeing the graph from -10 to 10. So if you want to change the window to see a different portion of the graph, you may. So when I go in the calculator here and I put this into y equals, get the inequality symbols by doing alpha window, I get the test symbol by doing second math. And then I do a zoom 6. It's going to show you the exact way it's supposed to be shaded. In fact, you can even count these and see that this is -2 and over here is 8. But how do we do this algebraically? The calculator showed me that it's inclusive. It's a push-in. The symbols are open because there's no equal sign here. And I strip the symbol, set x minus 3 equal to +5, and not forget to look at it through the perspective of the opposite side. So this gets set equal to -5. If this were a binomial, the whole thing would be opposite. Then I get my boundaries by solving for x. -2 on the left, 8 on the right. A lot of you still are having difficulty with the solution set here. These are indeed always going to be, if you put this smaller on the left and larger on the right, these are always going to be less thans, or less thans or equal to's if these are original is less than or equal to. For number 2, we have an absolute value equation, and the answer was -1 and 3. And you can see there is no shading here because it's an equation. So here we have the 3x minus 1 in absolute value symbols is equal to this binomial x plus 5. So we're going to create two equations. One is 3x minus 1 is equal to the whole exact thing. It's the exact equation with the absolute values stripped. This one, you can see that I changed only one side to all of the opposite signs. They just happen to be all negative, but they're all the opposite signs. So positive became negative, positive became negative. Then you solve them. A lot of you are forgetting to do this whole second equation, which is going to be at least a 50-point deduction. So I solve this and I get x is 3. I solve this and get x is -1. Now absolute value equations must be checked to see if you have to throw out an extraneous root. So put it back in the original, and they do happen to both check. Number 3 could have been done completely with the calculator. If you put this into the calculator, just like we did before, and did a zoom 6, you'd see that it's from -2 to 5. If you want to go back and do this just like we did with number 1, you may, but since it is a part 1, no work had to be shown. Of course, I'm always encourage you to do questions at least 2 ways. So I probably would have done this with the calculator first, and then on my second pass, done it algebraically. So the answer to number 3 was choice 4. I do just want to say one other thing on an aside here. I didn't give you any problems that had solution sets that diverged when out, to make sure that you do know how to write an OR solution set. So this had nothing to do with the problems. This is just an aside. This is a greater than or equal to. It looks like a Z, but that's a greater than or equal to symbol. Notice how they are filled in because of the equal sign. If you read this graph here, it's x is less than or equal to -1. Or, because you can't be in two places at the same time, x is greater than or equal to 5. So note with the inclusive, they're always in the same direction here. And the OR, you just read the graph. So it's always best to look at the graph first and interpret the solution set from that graph.